This video is going to help you learn how to do two new sorts of calculations. Before we continue any more on the video, can you please get yourself a piece of paper? You'll need your calculator and you'll need your data sheet so you can see your periodic table. As you watch the video, you're going to be asked to stop and do a step in the calculation. Can you please stop when I ask you to? Do the calculation on your piece of paper. If you don't understand what's happened or how you do that, go back and watch again before proceeding. And even if you don't understand, ask me tomorrow in class. So, press pause now and get your things ready. Okay, so all of this information is on page 31 of your notes. So the first calculation is percentage purity. Not all chemicals used in a chemical reaction are pure. If they're not pure, we can't directly convert those chemicals into moles to use in a calculation. So, an example, we have aluminium metal reacting with iron oxide according to the equation that is written. So the question is, we have 24 grams of an impure sample of aluminium. If it's 24 grams and not all of it is aluminium, I can't just turn that 24 grams into moles by dividing by aluminium's molar mass. But what I do know in the question is that I have 45.7 grams of iron. This will be the chemical that I know the purity of, I know it's pure, I can use that to directly convert my iron grams into moles. So could you please now stop the video and calculate the number of moles of iron that we have in this question. Okay, so hopefully you have now done the question. So our number of moles of iron is 45.7 grams divided by the molar mass of iron. So at the end of the reaction, we've had 0.8183 moles of iron. So now we can use this as our known chemical. This is the chemical that I can now use in my equation. I know my moles of iron, so now I can work backwards and work out my moles of aluminium that I must have started with, and therefore the mass of aluminium that was in my impure sample. So you're going to pause your video and now try to answer this question. So, stop and calculate. So, we're working with iron and aluminium. From my equation, I know that 9 moles of iron will have come from 8 moles of aluminium. In this question, I didn't start with 9 moles of iron, I started with 0.8183 moles, which we calculated on the previous page. So now I can do my cross multiply and work out my number of moles of aluminium that I must have started with. So hopefully you all have this number. You have started with 0.7274 moles of aluminium. I can now convert those moles of aluminium into a mass. So my mass of aluminium is now that number of moles of aluminium that I have predicted my iron has come from, multiplied by the molar mass of the aluminium, and I get 19.6 grams. So what does this mean? This means that I started with a certain mass of impure aluminium, and I've used my mass of iron to work out, in fact, how many grams of aluminium was in my sample. So the mass of my pure aluminium, which we worked out on the previous slide, divided by the mass of the impure, which was in the question. So, can you now use those numbers to calculate the percentage of aluminium? Again, press pause, do the calculation, and I'll show you the answer. So, in the previous question, we worked out that the mass of pure aluminium was 19.6. The mass of impure aluminium we started with in the question was 24.5. So my percentage of aluminium is my mass of my pure over my mass of my impure times 100, and I hope that you all got 81.8%. So, you cannot convert, so summarizing, you cannot convert impure samples directly into moles. Somewhere in the question there will be something that is pure that you can calculate the moles of. You use your equation, you work out your moles of your impure sample, and then from that you can work out the mass of the pure substance in that impure sample and then turn it into a percentage purity. The second type of calculation that we're going to look at today is percentage yield. Now, up until this point, we have assumed that all reactants will be converted into products. Now, in most cases, probably 99% of cases, this never ever occurs. Most reactions are not complete. They don't go with 100% of the reactants turning into products. So yield is a measure of, in fact, how much of our reactants have become products, and we express that as a percentage. So we're going to use the same equation as the last example, but this time I have told you that 1.35 grams of aluminium is going to be converted into aluminium oxide. What I would like to know is what percentage of the aluminium is now aluminium oxide. Okay, so first of all, our first step is to work out our moles of aluminium. This time I know that the aluminium is pure and it's reacting to form aluminium oxide. So you need to take the grams from the previous question of aluminium, which was 1.35 grams, and you need to change those grams of aluminium into moles. So press pause now and convert 1.35 grams of aluminium into moles. Okay, so we started with 1.35 grams, we divide by the molar mass of aluminium, and we had approximately 0.05 moles of aluminium. Now, that aluminium is going to react according to this equation, where 8 moles of aluminium is going to turn into 4 moles of aluminium oxide. So, you need to calculate how much of the aluminium could have been turned into aluminium oxide. So again, press pause, do your calculation. When you're finished, start again. So 8 moles of aluminium will make 4 moles of aluminium oxide. We started with 0.05 moles of aluminium, so we're going to make an unknown amount of aluminium oxide. If you can't see the mathematical relationship, then you do your cross multiply. What we work out is that X number of moles of aluminium oxide is going to be 0.02502. Once I know my moles of aluminium oxide, sorry, that should be aluminium oxide there. Once I know my moles of aluminium oxide, I can convert that into a mass, and I get 2.55 grams. So in theory, my original mass of aluminium can be turned into, if I had a 100% reaction, I would get 2.55 grams of aluminium oxide being produced. If we go back in the question, you can see we didn't make 1.55 grams of aluminium oxide, we only made 2.1 grams. Okay, so now I need to calculate my yield. I could have made 2.55, but I only made 2.1. So the next step and the final step is for you to work out what in fact my percentage yield was. So we started with 2.1 grams, but we should have made 2.55 grams. So my percentage yield is how much in fact I made divided by how much in theory that I could have made. When I do that, I end up with 82.4%. So you have 2 different sorts of calculations. Percentage purity allows you to calculate how much of my original sample was the pure chemical. Second one is about the reaction and how much of the reactants are converted into products. So now it's important that you now practice these types of questions. There is a set in STARWA where you can now sit down and practice these questions. And any questions you have that don't work, bring them into class tomorrow and we will have a chance to sit down and try them. Thank you.